Draw a tree diagram. Well, the first choice you get to make is if you're going to do beef, pork, chicken, or veal. After that, each one of those will branch off. Each one you have a choice of getting baked or mashed potatoes. And then after that, each one of those choices, so you've got 1, 2, 3, 4, 5, 6, 7, 8 choices. Each of them, you get to choose peas or green beans. So if you add all those up, that's 16 different outcomes, 16 items in my sample space. The way to do that without a tree would be to say you've got 4 choices for your meat, and then you've got 2 choices for your potato, and then you've got 2 choices for your veggie. 16 outcomes. 3 bands and 2 comics are performing for a student talent show. How many different ways, in terms of order, can these be arranged? So we've got 5 total acts. How many ways can they be arranged? That's a permutation. Anytime they say arranged, permutation, there's 5 acts and 5 slots to put it in. So 5P5. Another way to think about this would be to write out your list of acts. There's 5 choices for the first act, and then 4 choices for the second act, and so on. Or 5 factorial. Either one of these answers gives you 120. Second part. How many if the comics must perform between the bands? So that means that you're going to have a band, and then a comic, a band, a comic, and a band. Okay, so let's arrange the band members first. Those 3 slots, right? So we're going to say, all right, the bands. There are 3 bands, and we want to know how many ways to put them in those 3 slots. And then we want to know the comics. There's 2 comics, and how to arrange them in their 2 slots. 3P3 times 2P2, that's one way to do it. You get 6 times 2 is 12. Another way to think about that is, okay, put the bands in first. You've got 3 choices for this slot, and then you've got 2 choices for that slot, and then 1 choice left for that slot. That's the bands. And then put your comics in the middle. You've got 2 choices for this spot, and then 2 choices for this spot. 3 times 2 times 2, also 12. I also had to make a list of this just so I could see exactly how it went. I started by listing out my bands in slots 1, 3, and 5. Band 1, band 2, band 3. And then thought, okay, how many different ways are there to arrange those 3 bands? So I found there was 6 ways to do my bands. So then how many ways can I put my comics in there? Well, I can have comic 1 and comic 2 in all of these. So that would be the first 6 choices. Or then I could repeat this list again, except switch my comics around. Put C2 in the first slot and C1 in the second slot. So that's going to be 6 choices, plus another 6 when I switch the comics around. So that'll be a total of 12 choices. I sometimes find it helps me, especially with problems that are small like this, to make a list so that I can see exactly how these numbers are working out when I actually try to count up the ways that these are supposed to look. The call letters of a radio station must have 4 letters. The first letter must be a K or a W. How many different station call letters can be made if repetitions are not allowed? So the K or the W being the first one, well, let's see first how many different arrangements I can make of the third 3 letters, letters 2, 3, and 4. Okay, so I've got 25 letters to choose from. Now I say 25 because I already used one. I already used a K or a W. And then how many different arrangements, order matters, no repeats, can I make out of those last 3 slots, 25p3. And then I'll say, okay, well, I've got that, and then they could either start with a K or they could start with a W. So that's going to take that number of choices and times it by 2. Another way of thinking of that is to set out your places. How many choices are there for that first letter? Well, it's K or W, so there's 2 choices there. And then, how many choices for the second letter? Well, there's no repeats. You used up 1 letter, either K or W, so you've got 25 choices left. And then, for the third letter, you've got 24 choices, and then 23 choices. So either one of these ways will work for doing this problem, and you get this answer. So now, what if you can repeat? Okay, if you can repeat, then let's talk about the last 3 letters. The last 3 letters, it's repetitions allowed. That's going to be multiplication rule. So 26 to the 3rd power for those last 3 choices, and then multiply that by 2, since you can start with either a K or a W. Or you can put your slots out again. How many choices for your first letter? 2, K or W. And then, how many choices for your next letter? Well, we can repeat here, so all 26 letters are fair game. Same thing for the 3rd slot and the 4th slot. Either one of these ways gives you an answer of how many different ways can a city health inspector visit 5 restaurants in a city with 10 restaurants? So first question, can you repeat? No, he's not going to visit 5 of the same restaurant. He wants to visit 5 different restaurants. Okay, second question, does order matter? I'm a little iffy on this one. Let's assume that order does matter, that he wants to know how many different ways he can arrange his visits. So that would be permutation. There's 10 total restaurants to choose from, 5 slots he's filling it, 5 restaurants he's choosing, 10p5. How many different ways can 4 tickets be selected from 50 tickets if each ticket wins a different prize? So first, repetitions allowed. Note the same ticket isn't going to be selected 4 times. Next, does order matter? They each win a different prize, so the order matters because each person will get named a different prize. Anything where each thing is ranked or ordered or named differently, order matters, permutation. So there are 50 tickets. We're picking them into 4 slots, 50p4 or this number. What if they all won the same prize? What that does is it says then that it doesn't matter then what order we choose them because they all win the same prize. So everybody's the same. Nobody is named a different prize. So that's combinations, 50C4 or this number. How many ways can 3 cards be selected from a standard deck of 52 cards, disregarding the order of selection? Okay, first, are repeats allowed? No, because you're getting 3 different cards. So then, does order matter? It says disregarding order, so order doesn't matter. So that tells me combination. 52 cards. I'm picking a total of 3 cards out of that, so that's 3 slots that I'm picking. So 52C3. How many ways can a jury of 6 women and 6 men be selected from 10 women and 12 men? The way to do this is to pick the women and then pick the men. Since it's a jury, that's kind of like a committee. Each person doesn't have their own title, so that's a C, a combination. We don't care in what order they're selected, just what group of people is selected. So the women, that's going to be a combination. Let's see, there are 10 total women and 6 slots we're picking. And then, so multiply, we'll have a combination to pick the men. There were 12 total men to pick from for 6 spots. So 10C6 times 12C6, which is 210 times 924 for this total. These last two problems are a bit different because we are actually figuring out probabilities, not just counting. So the first thing that we need to do is figure out our total sample space. How many total different combinations could we have of this? So there is a 4-person committee, 20 parents, 5 teachers. So first of all, what's our sample space? What's our total number of committees, possible committees that could be selected? We've got 25 people altogether that are going to be put into committees, a committee of 4. So our total number of possible committees that could be selected is 25C4, or this number. Okay. Part A. What's the probability that we're going to get all teachers? So in our numerator, we're going to figure out the number of groups that have all teachers, and then in our denominator will be our sample space, the total number of ways we can select our group of 4. So how are we going to pick 4 teachers out of 5? So how are we going to get all teachers? Well, how many different ways are there to do that? There's 5 teachers total, and we want to pick a committee, so order doesn't matter, and we want to put them into 4 slots. That'll be how many different combinations there are of teachers over our total sample space that we already figured out. There's your answer. Part B. 2 teachers and 2 parents. Okay, so how many different ways are there to pick a committee of 2 teachers and then 2 parents? So let's do the teachers first. I have 5 teachers to choose from, and I want to pick a committee of 2 of them. And then I've got 20 parents to choose from, and I want to know how many ways to pick out 2 of them. So we'll use combinations, and then we will divide by, since we're finding probability, we have to figure out what's the chances of that happening out of our total number of choices, which is there. So there's the work, 38 over 253. Part C, all parents. How many different ways can I pick a committee of all parents? Well, there are 20 parents, and I'm choosing 4 of them for the committee. So 20C4 is the number of ways to pick out your 4 people of your committee, if they're all parents. And then to find the probability, we need to divide that by the total number of items in our sample space. Part D. How many ways to pick 1 teacher and 3 parents for my committee? So I'll pick the teacher and then I'll pick the parents. So how many choices to pick the parents? To pick the teacher. There's 5 teachers. I want to pick out a committee of 1. That's going to be 5 ways to do that, or 5C1. And then, so I multiply. I want to find a combination of the parents for the parents. So there's 20 parents to choose from, 4 slots they're going to fill. So 5C1 times 20C4. And then to find that probability, I'll divide that by the total number of combinations I could make. So your answer is 114 over 253. What's the probability of getting a full house? So since we're finding probability, we're going to use some counting rules, but then we also have to find the probability. So in our numerator, we're going to count up how many ways are there to get a full house. Then in our denominator, we're going to divide that by how many possible total poker hands there are. And then when we divide that number, then we will get our probability of getting a full house. Okay, so let's start with the denominator. How many possible hands are there in poker? Well, a hand order, you can't have any repeats. You don't repeat what card you get, and order doesn't really matter because you can switch around the order of your hand however you want. So that's going to be a combination, and there's 52 cards to choose from, and you are picking out 5 of them. So 52C5, that's going to be your total number of possible poker hands. So now how many of those, out of all those, that's a really big number, 2 million, 2.5 million. So how many ways out of those is there to get a full house? I have to admit I had to think about this one for a while. So what is a full house first off? It's 3 of a kind and then 2 of a kind. So 3 of a kind, that means like 3 kings, let's say. So first, let's think about how many ways are there to choose. Let's pretend you're just talking about kings. You want a combination of, there's 4 kings, and then you're picking out 3 of them. So 4C3, that's how many combinations there are of just kings, ways that you could pick 3 kings out of 4 cards, okay? So that's just kings, but now you don't have just kings, you have ace, king, queen, jack, 2, 3, 4, 5, 6, 7, 8, 9. There's 13 choices there. So we're going to say times that number by 13. Okay, so that's how many ways there are to choose your 3 of a kind. And then you need 2 of a kind. So you're going to have, again, let's say, I don't know, let's say you're getting 9s. Well, you got 4 9s, and you need 2 of them. So there's going to be 4C2 ways to pick out your 2 of a kind, if, say, you have a specific suit, like 9s. But now, how many ways are there to do that? Because you don't want just 9s. It could be any of those. So it's going to be a 12 here. Why 12 and not 13? Well, you already picked one thing here for your 3 of a kind. So now there's going to be 12 different cards left to pick for your 2 of a kind. So you'll have 13 times 4C3 times 12 times 4C2.